Alright guys, what we're going to do basically is fly through your exam review sheet that's coming up for next week. So I'm going to get rolling here. A lot of problems to get through. We're trying to get through the first half. There's 44 problems. We're going to simplify number one here. Basically I'm going to multiply each exponent by what I have on the outside. So that's 4 times 8, which is 32. This is z to the 24th. Finish. Okay, number two, simplify the following. I'm just going to distribute the 5 in. So this is 6 to the 10. This is t to the third. Moving our bar again. Okay, coming down here, I'm going to go straight across the top, right? So I'm going to get 4 x to the negative second, y to the negative 4, over, going across the bottom, this is 12 x to the negative 2, y to the third. Now, the negative exponents do move them, but since x squared is match up, they're going to cancel out. 4 over 12 is basically 1 over 3, and this is going to be y to the 7th on bottom. So negative exponent puts it on bottom, then it's 3 plus 4 to get 7. So they're your first 3. All right? Here comes 4, 5, and 6. Let's start with 4. We're going to multiply basically x into everything here, so that's x cubed. That's x squared. That to give me 6x. Going with the 7, which I'll do in red. So this is plus 7x squared plus 7x. And then plus a 42. Okay, so combine like terms. Shouldn't be too bad. We got x cubed plus 8x squared plus 13x plus 42. That would be it for number 4. Factor completely. I'm going to pull out a 4x here because that's what they have all in common. That's going to leave me with the following scenario. This is going to be x. And I'm going to try to go minus. Numbers that multiplied before that basically add up to 1. No such scenario is there, so I'm going to stop right at that. Okay, moving right along. Jumping down here to factor this guy. This is a difference of squares, basically. So 5y plus 4 and 5y minus 4. That one would be complete. No GCF. Right? Let's jump to 7, 8, 9. That's why 6 is the greatest of them. Right? So what I'm going to do is factor by groupings. This is a 4x squared I'm going to pull out. Leaves me with 1x minus 2. Go pull out a 3 here. It's going to leave me with 1x minus 2. So I'm going to get 4x squared plus 3 times x minus 2. And there you go. And number 8, we're going to find what basically this is divided by x minus 4. I'm going to do this in synthetic division style. There's no x squared, so I put a 0 there. So bring down 4. This is 16, gives me 4. This gives me 16. 16 times 4 is 64, gives me 16. And that would be 40 plus 24, which is 64, so a remainder of 4. So when I write this out, I am going to have 4 over x minus 4 as my remainder. I have 16 as my constant. I have 16x. I'm going to have 4x squared. And then I'm going to have 4x cubed. That would be it. Notice I work backwards there. Find all the zeros for 2x cubed minus x squared minus 10x plus 5. So p is 1 and 5. Q is 1 and 2. So remember, I want to go p over q. So I have positive negative 1. I got positive negative a half I can test. I can also test positive negative 5 and positive negative 5 over 2. So there are my combos I need to check. Now there's 3 total I need to find. So, actually I can pull GCF out. So this is actually more work than what I had to do. Just recognize this, that I can pull an x squared out. Leaves me with 2x minus 1. I can pull out a negative 5 here. Leaves me with 2x minus 1. So 2x minus 1's get pulled out. X squared minus 5 is equal to 0. So you can see this is going to be 2x equals 1, x is equal to a half, which was on my list here. Over here, though, these are going to be irrational answers. So positive, negative, square root of 5. So my three solutions, find all the zeros. It would be positive square root of 5, negative square root of 5, and a half. All right. Let's go to 10. Page 2. 10, 11, 12. Okay, what's it say? Find all the zeros of this function. So set each one equal to 0. If I do that, this one's going to give me negative 8 over 3. This one's going to give me 3 over 2, and it'll be negative. This is going to give me 7 divided by 3. So there's 1, there's 2, there's 3. So 3 solutions for 10. Write a polynomial function that has these zeros. Remember, this would be x equals 5, so x minus 5 equals 0 at some point. We have x equals negative 2, so that means x plus 2 equals 0 at some point. And x is positive 2, so that means x minus 2 equals 2. Which means that I have x minus 5 times x plus 2 times x minus 2 equals 0. Since I have a leading coefficient of 1, I don't need to worry about putting anything out here. So this is going to be x minus 5. This is x squared minus 4 if I FOIL it, because the inner and outers will cancel out. I now need to FOIL this. So it's x cubed minus 4x minus 5x squared plus 20. So my final solution is x cubed minus 5x squared minus 4x plus 20. Okay. All right, find all the zeros of the function, 15x to the 4th. Okay, this is your rational root theorem, which I was doing in the beginning one, but then I realized I didn't have to do it, so let's try this again. So 6 would be 1, 2, 3, and 6. Q is 1, 3, 5, and 15. We'll break it down 15. So this is my Q, this is my P. So if I'm going to do P over Q, it's basically 1 over 1, 1 over 3, 1 over 5, 1 over 15. Okay, and then I'll do the same thing for 2. So it would be 2 over 1, 2 over 3, 2 over 5, and 2 over 15. And then I would do the same thing for 3 and 6. But let's start looking, see if we can figure out what one of the zeros is a while. Maybe we can factor it after this step. So let's take a look. Okay, it doesn't skip any places, so that's nice. What should we test first? Well, I'm probably thinking maybe 1, but I don't think 1 will work, but let's try it. 15, negative 4, negative 4, negative 13, negative 13, this is positive 6, and 0. So actually that worked out quite well. So 1 is the solution. That's one less to worry about. It does not appear that I can factor this down at all, so I'm going to have to keep going with this rational root theorem. So now I have 15, negative 4, negative 13, and 6. Okay, I'll try 1 again. Highly unlikely that this is going to work, and it's not. Okay, so that's going to leave you with 4. So let me jump back, rewind this. Let's try a different number. Okay, let's try negative 1. So 15, this is negative 15, negative 19. That will make it positive 19. That will make it 6. This would be negative 6. Sweet. So what we're looking at here now is our second answer of negative 1. So we have 1, negative 1, and my other two answers are going to come from this. I don't think that's going to be factorable, because what I'm looking at here is 15x squared minus 19x plus 6 equals 0. So I want numbers that basically multiply to be 90 and add up to 19. Oh, so I can factor this. 15x squared minus 10x minus I come up with that? Well, minus plus is minus minus. 15 times 6 is 90. And I saw 9 times 10 multiplies to 90 and gives me 19. So my GCF, my first two is 5x, leaves me with 3x minus 2. This has a GCF of negative 3, leaves me with 3x minus 2. So it looks like my other two answers are going to be, well, 3x minus 2 equals 0. So x is 2/3. There's number 3. I have one more to go, and that's from 5x minus 3. So I need to buy a little bit of space here. So I'm going to set 5x minus 3 equal to 0. And this is going to be 3/5. So there are my four solutions. 1, negative 1, 2/3, and 3/5. I know I have four solutions because I have the fourth power polynomial. So let's go to 13. Okay, probability won't be on there, so don't even worry about 13. Let's go to 14 and 15. 14, f of x is 8 minus x squared, g of x is 5 minus x. So we're just going to do subtraction here. 8 minus x squared minus 5 minus 2x. So 8 minus 5 is 3, negative x squared stays as is, plus 2x. So to put this in decreasing order for your exponents, that's what you would be looking at. What is the inverse of the function? Blah, blah, blah. Remember, this is y equals 4x plus 2/3. Switch your x and y. And we're going to solve this for y. So I'm going to multiply both sides by 1/4. So what I'm looking at here is 1/4 x minus, basically 2/12 equals y. Now I can reduce that to look like such. There you go. All right, jumping down to 16, 17. What I'm going to do is I'm going to square both sides. So this is going to be x plus 20 equals x squared. So x squared minus x minus 20 will equal 0. So this is x minus 5, x plus 4. So x is equal to 5 and x is equal to negative 4. Negative 4 will not work. Positive 5 will work. Why does negative 4 not work, you ask? Because I cannot take the square root of 16 and get a negative 4. There's just no way that's going to happen. But if I put 5 in there, I get the square root of 25 equals 5. That's a half. Okay? Solve the equation at 17. Same deal. How do I get rid of a cube root? I'm going to cube both sides. This is x minus 8 equals negative 2 times negative 2 times negative 2, which means negative 8. So x is going to equal 0. Right? If you want to check it, you're going to get okay. This is a good solution. Right? 18. Right? So we're going to divide by 3 first. So I'm going to get x to the 3/4. This is equal to 64. I am now going to raise it to the reciprocal. So basically what I'm doing is the cube root of 64, and then I'm going to raise it to the 4th power. So this is basically 4 to the 4th, which is also 16 times 16, which is 256. Okay? And that will not be extraneous. Okay? And I don't have to worry about plus or minus because it was an odd root, not an even root. Okay? Here we go. FOILing time. So I'm going to square this side. I'm going to square this side. So this is x squared plus 5. That's the easy side. This is 9 minus 6x plus x squared. All right, x squared is going to cancel out, leave you with 5 equals 9 minus 6x. So I'm going to add 6x over. I'm going to subtract 5 over. Looks like I'm going to end up with 2/3. If you plug 2/3 in, you will not get an extraneous solution, so you'll get a positive value here. Okay, due to time, you can do the check on your own. This is where I'm going to stop because I'm out of time. So I'll catch you guys at 20 here.